Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSS sheet, and in this we were doing linked list topic. Pattern was fast and slow pointer, and today we will do the next question, which is remove nth node from the end of the linked list. So let's read the problem statement. The question says a linked list will be given, and suppose in the example number 1, as you can see, n is equal to 2 means second node from the end of the linked list we have to delete. And you know how to delete. To delete whatever node we are deleting, to like one location previous to it, we should have a pointer there. So suppose at 3 we have a pointer, so 3 dot next we have to connect to 3 dot next, and we can say yes, 4 has been deleted. About the deletion we have already covered in our previous video. I'll definitely recommend or add the link somewhere here, you can go and check it out. Okay, and regarding the different patterns of linked list also we have covered in the very first video of the playlist. You can also check that video if in case you have missed that. So in this case we have to delete. Okay, now let's see the constraint. Constraint says the number of nodes will be 1 to 30. We do not need to worry about the constraints much, because you know before getting TLE 10 to power 8 or 5 into 10 power 8 sometimes operations are eligible. In this case it's just 30, so it's very small constraint. Okay, so definitely we need not to worry about the time complexity here, but still we will try to optimize the code as much as possible. So let's try to understand if we have to delete the second node from the end, how can we do it if we do not know about any few patterns? So I have to delete this second node. So to delete we should have a track to this node. So after taking how many jumps I can reach this node? 2. Is this matching with this? Let's take few more example to check if it is correct. Like if we have to take exactly n jumps or not. Correct? Okay. 1, 2, 3, 4, 5, 6, 7. Here is our head pointers. Now suppose if we have to delete this. So what is n? N is equal to 2. Is it like, are we reaching this fifth node by taking 2 jumps? No. Okay, this is not valid. Then what? What is the total length? Can I say 7? What is the node we have to delete? Second. So 7 minus 2, 5. Do we need to take 5 jumps? 1, 2, 3, 4. Okay, 4 jumps. Here we need to delete second node. Number of like length was 5. 5 minus 2, 3. But we took only 2 jumps. Is it like total length minus nth node minus 1? Let's take one more example. Suppose in this case we have to delete this like 1, 2, 3, 4, fifth node from the end. So total node means 7 minus 5 means 2 or minus 1 extra. So only 1 jump. So is it like if we have to delete 3, we have to be present here. How many jumps? 1. Done. Means total length minus position minus 1 jumps we have to take. So how to calculate length? Definitely how? You know that key, you know the header you cannot move. So head will be as it is. Correct? You will take a alias current and you will write a while loop key while your current is not is equal to null. Correct? Move your like keep moving current at current dot next, and let's say you are counting length. So initialize your length with 0, and inside the while loop you have to do length plus plus, and that's it. So initially your current is here, correct? 1. So length is 0. Next time current is equal to current dot next and length 1. Current null? No. Next time 2. Next time 3. Next time 4. Correct? So you can initialize this with 1. So see, if you will initialize your length with 1, so total length 5. So formula to delete will be total length minus position minus 1. If you will initialize your length with 0, so total length will be 4 instead of 5. So it is already 1 lesser. So in that case length minus position will be enough. So make sure, be smart enough ki what will be the formula as per your initialized value. Okay. So in this case if you will initialize with 0, length minus position jumps you have to take. If you will initialize with 1, length minus position minus 1 jumps you have to take. I hope this point is clear. Okay. So now we have calculated the length. Now what? We have to take jumps. So you can either add in a for loop ki for int I is equal to 0 to what? Let's say position we have to travel. So position will be nothing but length minus n. So we have to traverse till position equal to, and we will keep on doing I plus plus. So now let's restart our current pointer from head. Okay, and now what we'll do, we'll just keep on moving current is equal to current dot next. Done. So now how many jumps? In this case, suppose we have to delete the very first node. So total length, because we initialize with 0, 4. 4 minus what we have to delete? 1. Total jumps 3. Start from this 1, 2, 3. You are at 4. Now after taking these many jumps, how to delete this node? Can I say current dot next is equal to current dot next dot next? Yes, because what is current dot next will be, what is the address 4 is saving? So 4 is saving address of 5th. And what is the address 5th is saving? Null. So if we want to delete 5, definitely we have to store what 5 is storing. So after coming out, we just have to write current dot next is equal to current dot next dot next. What is the time complexity? O of n to calculate length. If in case of like if you have to delete this last node, nearly O of n only, that many jumps. So O of n to take jumps. So in total O of 2n. Space complexity constant, because we have not taken any extra space to save our nodes. So in total time complexity is O of 2n. In linked list you will see all these kinds of 2n, 3n as your brute force approach. Can we optimize it further? Means can we do this in just one iteration? Is it possible? Yes, it is possible. But before doing that, let me show you the code for this. Okay, so I have already written the code for you. Initialize the length and current, and until the current null, keep calculating the length. So this while loop is to calculate length. Now calculate the position as length minus n. Again, the base case. What if your position is 0? So definitely you do not need to take any jump. Means the position you are standing, the current where you are starting, means the head itself you have to delete. So if the head itself you have to delete, so you will simply return head dot next, saying head has been deleted. Or else what I said, reinitialize your current with the head, take position jumps, move your current ahead. After coming out, just put current dot next is equal to current dot next dot next. So exactly the node which you want to delete has been deleted. Now after deletion, you can just return the head, because the question asks to return the head again after deletion of that nth node from the end. So the time complexity will be exactly O of 2n. So as you can see, it has been passed. So let's submit. Now submitted also. So this was a brute force code like in 2 iteration. Can we do this in a single iteration code? Let's try to understand. So as I already told you, using the fast and slow pointer, so definitely we are going to apply something like similar concept. Okay, so when we have to delete this node, we took that many jumps. Okay, so see, let's try to relate this with real life example. Have you seen that track which are in oval shape? Yes, you might have. And you would have seen one more thing. What? Ki those who were in the inner circle needs to start from far, and those who are from outer circle needs to start from lesser distance. And we always thought, hey, why this, like suppose this is A and this is B, ki why this B is always ahead? Because the track length is longer for B compared to A, correct? So to make it fair match, we already moved B ahead. Can I say that? We will use similar concept here also. What concept? We need this node, correct? So what I am saying, see, when I say fast and slow pointer, it does not always mean ki fast will always move with 2x speed compared to x. No. Fast means fast will be ahead of slow. So if in this case we need this node, means what node? 2 nodes. So what I am saying now, so let's take exactly n plus 1 jumps. N plus 1 means fast will be here. So fast will be at 4 and slow will be at head. Now let's move both of them with the same speed, because here what we wanted means the fast needs to be at length minus position distance. We have already kept it. Now what we'll do, we'll move this with same speed. So slow will take 1 jump, fast will also take 1 jump. Now slow will take 1 jump, now fast will also take 1 jump, and now fast is null. So we will stop, and now the position where slow is pointing to, just next node we have to delete, and you will get that always. Let's take another example, a bigger one. Now let's say here we have to delete n is equal to 3rd node. So how many jumps we have to take? n plus 1, 4. So 1 jump, 2 jump, 3 jump and 4 jump. So fast will start from here and slow will start from here. Now next time slow will move for 1 time, fast will move for 1 time, correct? Now next time slow will move for 1, fast will move for 1. Again slow will move for 1, fast will move for 1. Again slow will move for 1, fast will move for 1. Now fast is null, will stop. What was the node you wanted to delete? Third means can I say sixth? And I am exactly present just one node ahead. Why? Because I have to connect this node to this so that 6 will get deleted. Correct? So this is what we have to achieve by relating with the real life track system. Okay. So whatever node we wanted to delete, we already kept that many distance gap between the slow and the fast pointer, and we tried moving both with the same speed. Okay. Now why not n jumps and why n plus 1? Because if we have to return the node which we want to delete, we would have take exactly n jumps, means n gaps between slow and fast pointer. But because here we have to delete that node, so to delete that node we should have present one node ahead of what we have to delete. So that is why we have kept n plus 1 gap between slow and fast. Okay, so to keep that n plus 1 gap, we have to make n plus 1 jumps for fast pointer, correct? Now let's see the base cases. Base cases means what if there is only one node and that exact node we have to delete. So can I say if head is like head dot next is null, n is equal to 1, return null? But there will be a lot of mess, correct? Why don't we do one thing? That is, let's start a dummy node. Dummy node means let's start with 0 and attach it to head. Now suppose even though we just had one head node, that's it. Okay, so n is equal to 1 means n plus 1 jumps will take. So after taking 2 jump, fast will already be at null, and let's say slow we will start from head node. Now because the fast is already null, so slow will not move, and now slow dot next we will connect to null. So now head will automatically get deleted, and now what we will return? Will return slow dot next because the question asked head pointer. So in this case when you deleted 4, you cannot return dummy node itself, correct? From 1 itself, like from 1 onward the linked list should return. So we will return dummy dot next. Again saying why we have created dummy node, because if in case we just have head node or else head dot next, means you can take care in the head or head dot next also, but there will be a lot of if else cases to check your base cases. So if you will follow this dummy node rule, you don't need to take or check multiple base cases. So let's write the code for this. So let's make a dummy node. So list node type, correct? Let's call it dummy is equal to new list node with 0 value. Key the very first node will have value 0. Now in the dummy dot next we will attach head. Now the whole linked list will look like 0, 1, 2, 3, 4, 5. Okay. Now we'll start our slow and fast. So list node slow is equal to dummy. We have to start from dummy, and list node fast is equal to dummy. So we'll start from dummy. Now we have to take jumps. So for int I is equal to 0, correct? I less than equal to n means n plus total n plus 1 jumps, correct? From 0 to n means n plus 1, and I plus plus. So we have to take jumps but for fast. So fast is equal to fast dot next. That's it. Now what will happen? Now fast is like we have a gap between slow and fast, and that is exactly n plus 1. Now we have to keep moving slow and fast ahead. Fast is equal to fast dot next. Slow is equal to slow dot next. But until when? Until our fast becomes null. So in the while loop we have to write until our fast not is equal to null, correct? We have to do this again and again. So we'll do this. Now if our fast become null, we'll stop, and wherever our slow is pointing to, we have to just write slow dot next is equal to slow dot next dot next. Now this line will actually delete that node which we want to delete. After coming outside, after this line we have to return head, and head is nothing but dummy dot next. That's it. So now we can run the code. As you can see, it has been passed. So let's try to submit the code. Done, submitted. So what is the time complexity? As you can see, fast is moving, yes, with double speed and whatever gap we took, but exactly O of n times we have run, correct? Means even though we have moved our fast, let's say 5 jumps, but now in this while loop we are running fast from the same location until it becomes null. Means as you can see here, suppose 5 have taken these many jumps, means 4 jumps, and now in the while loop we are checking until the fast becomes null. So we are running the while loop only for this much distance. So in total this jump and this much distance in the while loop together makes exactly O of n. Means this is one iteration solution. So if you understood, this was a Java code and here is your C++ code if you are from C++ background, and here is your Python code if you are from Python background. So I hope you understood the reason. I hope you understood why we apply fast and slow pointer, and not always fast means it will move with double speed and slow means it will move with single speed. Okay, so I hope you understood. If yes, then definitely you can go in the sheet and mark the 4th question also as done. And if in case you have any doubt, please reach out to me through the comment section or the social media links. I'll add the social media links and the sheet link in the description below. You can definitely check it out. And that's it for this video. Let's meet in another video with some more interesting questions, topics and patterns. So then keep learning, take care of yourself and your family too.